Alright, it's been a goodly while since we've done a kit build, so I figured I'd do this kit that I keep forgetting that I have. This is another metal detector. Got it quite a while ago. I kept forgetting I had it. I think I got it somewhere around Christmas. But this one is a little different because it has a buzzer, so it actually beeps when you get close to some sort of metal. The interesting thing is there's no oscillator circuit built into the circuit here, so I'm wondering if the buzzer is its own self-contained oscillator. So I'm going to test that real quick by doing this. Okay, so that's got its own, wow, that is really flippin' loud. That's got its own oscillator built into it. So that answers that question. Alright, so we'll just go into this like we normally do. Start with the resistors. There are only 3 of them. So let's start over here with the 2K. That's going to be, 2 is red, and then we need 3 zeros, so 2 red, black, red, I guess, would be in this case, because these are 4 band resistors. So we'll just quickly fold that over and slide it in here. We'll do all the resistors at once, so I'll just get them into place with a little bit of a friction fit there. So R2 is the 2K. Alright, R3 is going to be 470, which is going to be purple, yellow, purple, brown. One of my more favorite color combinations. Although I found one that was purple, black, silver, which is pretty awesome. I like purple, black, and silver. Those are my favorite colors. Anyway, and the last one is R1, which is a 200K resistor, which is going to be red again, with black and yellow. And we'll just throw that in there, get in there, there we go. And we'll flop this over and solder it into place. Yeah, it's on. I installed a new firmware and the display is a lot different. I think there's a different setting in the firmware for the display. I might have to mess around with it. I still have to do a tutorial on the use of the custom firmware. Keep forgetting about that too. The life of being not entirely mentally stable. That's alright. I forgot to check to make sure that resistor was level. I'm just going to quickly solder those into place. Flip it over. Yeah, this one needs some adjustment. There we go. Oh, that's toasty. Come on. There we go. Okay, this one also needs to be leveled. There we go. This one also needed to be leveled. Alright, so now those are nice and level. Where are my decks? There they are. Diagonal cutters. It's a nickname that my... Oops, no, I need to finish soldering them. Boy, I am out of practice. I have got to spend more time in the workshop, don't I? Alright, so we'll just add a little solder. These are plated through holes, so the goal is to actually get a flat bead of solder rather than having the wick that goes like this. The goal is to actually have it be flat because the solder wicks into the plated through hole. That's something I'm actually not entirely too skilled at because most of the PCBs I work with are just pads instead of plated through holes. So with the pads you actually want to make sure that you have a reasonably generous meniscus of solder in place to hold the component. Anyway, so I think the next option we should do would be the capacitors that form the oscillator for the antenna. Now, the way this works is you have 2 antennas. One provides a oscillating, RF field, and then using the potentiometer here, you adjust the resonance of the second antenna so that it cancels out when there's no metal. But when you bring the metal into the situation, it basically changes the inductance of the first antenna, changing the frequency, and then the circuit falls out of balance and the buzzer gets triggered. I'm not too up on the exact specifics of how the circuit works. RF stuff is... I didn't learn much about that in school. It was more of the analog electronic stuff. And a little bit about FM and AM, and we did that, but resonance with inductors and stuff wasn't covered very well, so I will be learning more about that in the future and doing some stuff on the channel about it as well. But anyway, so capacitors. C3 and C2 are 222 capacitors, which is going to be 2, 2, and then 2 zeros, so 2200 picofarads, or 2.2, or 2200 nanofarads, or 2.2 picofarads. I always get pico and nano mixed up, which is smaller, and I may yet still have done that, but either way. Just quickly solder those pins in place. Check the alignment, although they aren't, super important to align nicely. Actually, nothing's too important to align nicely unless you just want it to look nice. So we'll finish soldering those into place. Find my dikes again, there we go. There's my phone going off in the background, if the microphone picked that up. It's pretty sensitive, so it probably did. Now, more capacitors are the 104, so that's 1000 picofarad, or 10 nanofarad, or sorry, 1 nanofarad. So those are going to go in here. So we got 1 nanofarad and 2.2 nanofarad capacitors. These ones are going to be a little spragnest. I'm probably going to want to straighten them out a little bit. I need to set my phone to do not disturb before I start doing videos. Alright, so that's nice and straight. And we'll reorient that one just a little bit. There we go. Alright, now we're gonna tack the rest of these leads on. A little bit of solder, that's all we need. There we go. I actually like the plated through holes because they hold components a lot more securely. There we go. I'll clip these off. Need some more diagonal cutters because I've been abusing these ones. Alright, the next components we'll do, what do you think is next tallest on the board? I guess that would be the transistors. So we've got 9012, 9018, and a 9012. I forget, I should know these ones off the top of my head as to which one is PNP and which is NPN. It's important for the circuit. I just don't generally pay that much attention to it unless I'm actually, building a circuit that is dependent on them. And, of course, I can't find my component tester when I need it. The funny thing is, I just moved it the other day when I was playing around in here looking for something. Of course, now I can't find it again. Well, I'll attempt to remember to put the 9012 and 9018 definitions in the description of the video because I can't find the component tester. Anyway, so I like it when they do this. The pitch on these leads is pitched so that it actually holds the transistors exactly. I don't have to really spread the leads at all. This one is the other 9012, so that goes here. Don't get those mixed up or the circuit won't work at all. I've done that in the past. I did do a back to basics video on the difference between PNP and NPN transistors and why they work the way they do. One, to open the gate you pull it negative, and the other, to pull the gate you pull it positive. and that's in my Back to Basics playlist, which I will also try to remember to put in the description. So I'm just going to solder these into place. No need to adjust them because the board is holding them quite securely in place. So I'll just dab a little bit of solder into the pads here. There we go. Turn these off. There we go. Gotta remember to keep the banter going so there's no quiet time, and I'm going to silence my phone. Sorry about that. There. Now it's on Do Not Disturb. Okay, we'll just set that off to the side so it doesn't bother us anymore. So I think the next component I'll put in will be the potentiometer. That'll be nice and easy to click in. It just goes here. It's a 100 ohm little potentiometer, although it is being used, I believe. Yes, it is being used as a rheostat. You can always tell if it's being used as a potentiometer or a voltage divider if you have two outputs on the thing, but in this case 2 of the legs are tied to ground, which means it's being used as a rheostat or variable resistor. Actually, we may as well throw the LED in while we're at it. The negative lead is the short lead. Goes there. Because the rheostat's holding itself in. As usual, my throat's getting all gloppy while entering for the video. So, just solder these into place real quick. Make sure this LED is nice and flat against the board. I put way too much solder on it. And finish off that. There we go. I get some criticisms for my soldering technique because a lot of people, they break off a piece of solder and they just work with a little leg of the solder. But for me, because I constantly lose the little bits of solder that I break off and I hate wasting, I just solder directly from the reel. I used to have a solder stand with a little guide that you just pull the solder out and then you can reel it back in as you desired, but that was amongst the many things that were stolen, and I had to flee an abusive relationship, the psychological effects of which I am still feeling to this date. But enough about that. Now we're just going to solder the button into place, and that's not quite level, so we'll give that little touch up, and we'll go ahead and finish soldering the pins. This is a 3-pole single throw switch. It's been configured for being a 2-pole single throw switch, I believe. The terminology has always confused me, but no matter. It's a nice little push button. I like this style of push buttons. I got some in a post bag just recently, which is actually probably going to go up at the same time as this video, because I've been very remiss in uploading, so I'll probably give you guys a 2-upload day just to kind of make up for that. So I'm going to throw the electrolytic capacitor into place now. I'm definitely going to have to push that one flat on the board after I solder it. So we're going to put a little bit of solder there, and then there we go. Get it nice and flat, and then solder it into place. There's that done. I'll trim off some more. Alright, only 2 components left to solder into place. The buzzer, which I'll do now. Very ambiguous positive lead marking here, but Oh yeah, I figured that out earlier. Nice obvious mark on the ground plane here. I wonder why there's so much ground plane on this. Big ground plane on the back and on the front. I wonder if that's to prevent interference from the circuitry, although this doesn't seem like the kind of circuitry that would interfere very much with this sort of thing, but I guess they have a reason for it. There we go. Just make sure that's nice and flat. Flush to the board, and then finish it off. I kind of like the way they've done the attachments to the ground plane here. It's not great if you have a high current circuit, but instead of having the pads just directly connected to the ground plane, they've got it attached with these spokes, which reduces the amount of current you can put through the circuit, but it makes it a lot easier to solder because you don't have the ground plane leaching away all of the heat as you try to solder the device together. Alright, and then last but not least, the power connector, which for some reason they've decided to go with this thing, but that's alright. It's going to take a little bit more heat because it's got very thick wires on the bottom. Actually, that soldered on a lot more readily than I thought it was going to. Let's tap that to level it out. And then give it a little bit more solder over here. There we go. Alright, and that is that kit completed. We're almost out of time on the meter here, but hopefully I can quickly... these are not long enough. I need 3 volts quickly. Oh hey, I know what I will do. I need a screwdriver. Little flat screwdriver. Yes, that is not a flat screwdriver, but I have the kit here, so I'll put that there. Heard me while I fiddle around in the background. I might have to do a bonus video just to quickly demonstrate the operation of this thing, because I'm about to run out of time. So we'll move the arc layer out, put the positive lead in here. And the reason why I don't stitch videos together anymore is because my computer is basically dying. Needs a new hard drive, and at the moment I can't afford a new hard drive. There's a good possibility that we'll be having somewhat of a windfall in the near future here, and we'll be able to start affording better equipment and more stuff for the channel, so I can start doing slightly more interesting activities on the channel. Possibly even an oscilloscope. A good oscilloscope might be in the future of the channel as well, so wish me luck on that. And I tell you what, I'm going to go ahead and wrap this video up here. Well, let's turn this on to make sure it's working. Oh, jeez, that is really loud. Okay, so that's working. I'm going to plug that up so that it's not so loud and do a quick follow-up video on how to set up and use the thing. So, thanks so much for watching. If you haven't already, consider clicking here to subscribe. Right over here is a video that YouTube thinks you'll enjoy from my channel. Right here-ish is the Kit Builds playlist. And right here is a link to Patreon, which you can use to help me buy things to do stuff. So thanks so much for joining me, and see you next time.